should be live.
There's an advertisement.
Yes, there will. I guess for some people, there will be an ad.
I'm seeing a Fortnite ad.
Us plebeians. Yeah, I'm also seeing Fortnite. New raps and emotes.
It's good. We're all. I mean, I guess I'm not seeing the ad, but anybody else would. Okay. So we're doing a demo day today. It's day 20 of the Wanix from Scratch stream. And Tara is here as usual, but we also have Joelle. Say hi.
Hey there.
And they're just accompanying me while I give, I guess, kind of a practice run of the demo that I'm putting together for Wanix. The idea was it would be done and we could watch it, but I still have to do some voiceover stuff and timing. So right now there's the timing might not be perfect, so I'll kind of be pausing and stuff throughout the video. But yeah, I figure it's just to make this easy. I'll just kind of talk over the video, and then if you guys want to ask questions during the video, feel free. Since I'll be pausing it and stopping anyway. So, what else? Anything else to go over? I mentioned this will be a pretty short stream. I think the video content is maybe 15 minutes. So it might be stretched out to 20 minutes and then talking after. So it could be as short as like a 30-minute stream.
I guess we could say your final demo video will be on YouTube at some point.
Yeah, and this will be on YouTube as well. But I don't know when the finished demo video will be done. Maybe in the next day or so. As well as the release. The whole point of this is that we kind of got to at least a preview release, which is not online yet, but it's all in main. You can check out from source and play with this thing. I guess that's pretty much it. We can get into a demo now. If I switch to the right screen.
Uh, well, I already know so much about what this is, so I'm a little biased, but I guess there's something between you and the hardware. That's what I think of virtual environment. So kind of small talk like where there's a VM between you and the silicon. Um, there's a lot of yeah. And not just modern software, but ancient software too. So, you know, or even just software I wrote for Python 2 10 years ago. And, you know, not having to deal with that, just keep on chugging along without spending 4 hours to do a 10-minute change. But yeah, totally. it's like a unified way of doing that. It's not like you have to have separate rules for how do you control access to the disk versus CPU versus network. Well, you can kind of picture it. Each of those colors could be a service. So /dev could be a service that gives you device interfaces. /temp could be tempfs.
Yeah, sure. Say something else. Say something else. Say something else. Say something. I think maybe not. But yeah, my voice is was like echoing.
Copy. Something had to go wrong, but at least it was fixed.
They said, "Wait, just heard you."
Test,
They said, "Wait,
test,
just heard
test,
you."
test.
They said, "Wait, just heard you."
Okay,
Yeah,
cool.
I do hear
So
you now.
luckily, most people on the stream have been looking at all the stuff I've been. We had this problem before, but yeah, the stream has not been getting my audio this whole time. So everything that I just explained has just vanished into the ether. But at least you guys heard it. But we're about to get to the actual demo part, so there will be a more produced version of everything that I just said in the actual demo, so that's fine. But now everything's working, and we can get into this. Are we in a shared room behind the scenes? We're in a shared Discord call. Yeah, no. But the actual demo is basically starting now. So really appreciate pointing out that the audio wasn't working so that we could get it working in time for this. Important bit, getting into the actual demo. All right, are you guys ready?
Do
Let's
it.
see if this will,
Let's go.
will work. Okay. So I'm just gonna hang out with this down here. All right. So, and you can mostly follow along. I think some of this stuff doesn't work yet on Wanix.run, but you can go to Wanix.run and play around with it, and try and do some of the things that I'm doing here. But this is a debug page, so that we can kind of build it up from scratch. And the source for this page is literally just include Wanix, and it's an empty body. So first we'd create an instance of Wanix, and this is going to register a service worker, so we'll see some logs. And then we called it with helpers true, which is going to give us some convenience functions. But so Wanix now, what is this primitive? If we looked at kind of what methods that we have on this W object, which you have to use this object get prototype of just to get a list of methods. But these are the methods that are on W, and you can see that they're basically file system operations. And then that's pretty much the only API that we're using this entire demo. And we're not going to be using all of these. There's just a couple of high-level things that we'll use, like read dir, read file, and write file. And that's pretty much what we'll be using. So it looks like, these are all asynchronous, so you have to call await. And so if we look at dot, which in this case is the equivalent of root, because in a world of namespaces, there is no real root. So, and in this case right now, there's also no current working directory. So what dot means here is basically root. And so if we look at the root of this virtual file system, it's not empty. It's actually got some stuff in it. And we'll look at those in a bit. But basically, these are things to help bootstrap our environment. So this await stuff is kind of annoying to write. So we'll use these helpers that I mentioned before. So instead of read dir, we can just say list. But we will get this undefined because it's asynchronous. So we'll see undefined after everything, and then the actual output. So let's play with this a little bit. We'll look in web. Web has a bunch of stuff for the web environment. We'll see in a bit. And we have web OPFS. And a lot of people don't know about OPFS. That's the Origin Private File System. It's a storage. It's like a domain or origin specific file storage, like local storage, except it's a file system. And you get kind of a file system looking API. And you're not intended to see this on your host system. The browser's going to manage it for you, just like local storage and everything. But it's sort of an obvious thing to make into a file system that you can use here. So looking in web OPFS shows us there's a couple directories in a file, and that's what's actually stored in OPFS. Unfortunately, OPFS doesn't have an interface in DevTools yet, which is a little weird. So you can't inspect it that way, but you can use Wanix. Anyway, OPFS is one of the only file systems or file services that behaves like a normal storage volume. Almost everything else is going to be more like a device file kind of thing, where it's an API to something. So we'll look at that next. Well, first we'll write a file in here. So writes a file. You can see now it's in there, and this will persist. If we were to reload the page, it would still be there, right? OPFS is persistent on this browser, on this domain. And then we can use read to read a file out. So now let's look at a dynamic file system, and this is kind of representative of how things are done often in Plan 9, where you have a directory for some resource. For example, TCP, there's a /net/TCP, and you use that file system to make TCP connections or sockets. And the way you do that is you do something called a clone dance, where you create a new, almost like an instance of a socket, and it creates a directory, and then that directory is full of device files specifically for that socket. So we'll see how that looks here in Wanix. If we look under new, we can see the types of resources that we can allocate. So CAP is short for capability. It's sort of a general purpose like file service manager. And so these are some of the different file services that we could instantiate here. TempFS looks familiar, TarFS, maybe you could imagine. But we're going to use PickerFS, which is actually part of an API in the browser that lets you pick a directory on your host system and then gives your browser access to that one directory. So that's exposed here as a capability. So to create an instance of this, we do this clone dance. It looks like this. We're going to do a read on the file, and this is going to allocate it, and then it returns an ID, and then that ID is now a directory under CAP that we can use to interact with this. We can read type to see that this is a PickerFS, but it hasn't been mounted yet, and the way we would mount it is to use this control file. And so this is another big pattern in Plan 9 is you can do a lot through the file system because control files are almost like command line tools. You open them and then you write to them a line that looks like a command line arguments. And then it'll do that operation. So it's almost like having a built-in command line tool. So the control for this capability that we just allocated takes a message or a command called mount that will actually perform the mount it into the file system, but it needs to ask you what it needs to actually let you pick. So the browser gives us this dialog. It's the source for Wanix I just picked. And so now there's a mount directory under this capability that has all of the files from my host computer. And this is a read-write mount. So if I were to write files in here, they would show up in the directory. And if I were to change files and read them here, they would be up to date. So just an example of a capability, but also a kind of typical like device resource or non-storage volume file system. But anyway, this pattern is going to be used a bit. So that's pretty much the basics, but it's kind of boring, maybe a little tedious to be doing all of this with these little helpers. We don't have the richness of like a full shell experience. So we have one final helper here called boot shell that's going to give us a shell, and then we can actually start the real tour. Now that you have the foundations, and then at the end we'll kind of look at what this boot shell is doing, because it's basically bootstrapping a shell from itself. But we have to kind of learn more about the primitives. So boot shell gives us something that looks like a shell. So for people that aren't familiar with shell stuff as much, we'll kind of go over the basic stuff that you'd have in here. We have a working directory, so operations can be specific to a particular path or relative to a particular path. You can use ls, obviously, to list, and you can see this is the same file system we were looking at before. We've got our hello.txt. We can use echo to, any arguments to echo our output as a line in standard out. So normally this is kind of a useless command, but because Unix shells have output redirection, you can use this as a way to construct the output that you will then redirect into a file. So writing a file looks like this. We do echo file, and then we redirect that into file. So now there's a file that has foo in it. And then we use cat to output a file to standard out. And if we use double arrows, that appends to the end of a file. So if we cat file now, it has 2 lines. But those are basically the same operations that we were doing in the dev tools before, but this is how you do it in sort of like the Unix shell kind of way. So that's how we'll be reading and writing files from here. Let's just go. Okay, DOM interface. We have a file interface for the DOM. Since we're on the web, might as well interface with it. We can see here we're looking at, so one is an existing resource, and we went into that directory, and then we catted type to see like what type of DOM resource is this. And it says xterm because this is actually the xterm JS terminal that we're looking at here. So you can kind of use now the file system to inspect the DOM to some degree. For example, we could also cat its attributes. And so we can use it to inspect the DOM, but we can also use it to manipulate the DOM. So there's a style file here. It's a device file, so it doesn't work exactly like a normal file, but we can append into it new CSS styles. So using echo, we can create this border style around the HTML that'll give us a light green border. And then we append that to style. And now our page has this style, so we have this border. We can also create new DOM elements. Looking under new, you can see which ones we can allocate. But now that we're in a shell, we have variables and subshells, so it's a little easier to do this clone dance thing. But we're making a variable called ID, and then we're using cat to read new iframe. And so that gives us an ID, which is now in ID. And so we can use that to work with the file system to say, what is the type of this thing I've allocated? And we don't see the iframe yet because we haven't appended it to the body. So we can send a control message to the body, body's control. So here I'm just showing you all echo is doing is taking the arguments and generating a line, and then we can use redirection to sort of pipe that into a file like the body's control file, which performs the append child. So now we have this iframe, which we've added some CSS and JavaScript so the iframes basically behave like windows, and it sort of intentionally looks like a Plan 9 window or a Rio window. But this is just an iframe element absolutely positioned that we can drag around and resize and stuff. But it's literally just an iframe in the body. And we can control the navigation of this iframe by changing its attributes. If we change its source attribute, we change what it's going to load on the page. So we can echo source equals root, which will take us to Wanix run with the console. So this should give us kind of a subshell. So we made a little subshell window. Already kind of feels like a little operating system. We can remove by sending a remove message to this iframe's control file. And there is shell scripting, so we can make conveniences. We could make something like dom cuddle that effectively does, the commands that we would normally do, just to kind of make things a little bit nicer feeling. So let's look at the source code for this dom cuddle that we have sort of built in here. So it's a really simple shell script. It either takes new as the first argument or an ID. And if it gets an ID, then any other arguments are just echoed into the control file for that ID. And then new, if you don't specify an argument to new, it's just going to list, what types of things you can allocate. And if you do specify an argument, then it will allocate it. So let's see what doing a new DOM element using this will see how it sort of cleans it up. Skip ahead. So we could say ID equals DOM cuddle new iframe, so that allocates an iframe. DOM cuddle body, append child ID. So there we go. Feels a lot simpler. And it's just from that really simple script that's wrapping these file system operations. And Plan 9 is actually full of these scripts. A lot of the things that you'd normally use a full program for or whatever, you can now do through the file system, but then they would have these shell scripts that just kind of make it a little bit more ergonomic, I guess. So we install a service worker, which is used for a lot of things. One of them is caching. So when Wanix loads, it will cache everything it needs to load so that it will basically work as an offline application. So sort of local first friendly. But the service worker is basically a proxy that lets you handle any of the network requests that are made on the page. So it's supposed to be made for that kind of caching, but we can also use it as a way to let us interact with our file system or our namespace through sort of paths as if it was serving that file system. Let me give you an example here. We'll create another iframe. And this time we'll go to this element, and here the source path that we're going to give it starts with this /: prefix, which is currently what the service worker uses to say, open this path from the file system. So this sort of not coming from the Wanix.run server, it's coming from the service worker that's installed, which is then getting it from our file system. So we can reference the file that we made earlier, and we can just point our iframe at that file by setting its attributes. And then we have foo and bar. Remember foo and bar? So that means we can also write, an HTML, a really simple like HTML file or snippet to a file, hello.html. And then we can just point the iframe at that, and we have a easy way to sort of render HTML in this environment. Something Plan 9 can't do because it doesn't have a proper browser. So we also have web workers, which are sort of the generic, service worker is a specialized web worker that's made for handling network requests. But you can also use web workers just as sort of like background threads. We have a file interface and convenience helper script for web workers. So if we wanted to run this worker.js, which is just going to output to the console every second, we could use worker ctl start to start this web worker. You can see it running down there. We can go into this worker, see that its state is running. We could also echo terminate into its control file, which you can see now it's not echoing anymore, and its state is terminated. So you can manage web workers through this simple file interface. So that's something that we had to get into to build up to something like WASI executables. So in previous versions of Wanix, you could really only run programs that were compiled with basically a custom Go compiler. And one of the most requested things from people was to run WASI, which is a special format of WASM that conforms a little bit to POSIX conventions. So it's sort of what you'd expect a WASM executable to be. And we didn't support WASI. It's kind of a challenge to get the support, but we now have WASI support, which means any language that can compile to WASI WASM, that program should be able to run in Wanix. So as an example, here's a Zig program, and Zig compiles to WASM, and look how tiny it is. It's like 28 kilobytes. But how do we get this WASM file into Wanix? I mean, we could use that picker.fs from before, but we'd also just drag files onto the terminal, and that will put them in your OPFS directory. And so now we can just run zigcheck.wasm. So this check file is basically printing out its own environment, what arguments it got, what working directory it's in. Working directory is not a WASI supported thing right now, so that's going to be inconsistent for different languages. Obviously, environment variables, but maybe more important to the idea of the environment is what files does it see in its file system. So at the bottom, you can see it outputs what it sees is the root file system, which is what we see as the root file system: cap, task, and web. So that's good, and we can, I've tested Rust and Go, and try any language that can compile to WASI, and it should run in Wanix. So WASI executables, yay! But this gets into tasks and namespaces. Let's see. So that WASI executable was run as a task, and a task is Wanix's equivalent of processes. So there's a /task that's very similar to /proc on Linux. So here we can kind of go into this directory to see the WASI thing that we just run, and just to make sure we can cat command to see that, zig check, that's what we ran. We can also see the namespace that it used when it ran. We can actually go into that namespace and see cap, task, and web. They're subdirectories. You can imagine going into task here and 2, it'll just loop around. But anyway, that lets you kind of see what that process sees. And it's done now. So we'll make a new process, and by making a new task manually, we can customize its namespace. So we're creating a new WASI task, and then this is kind of cool. We're copying over the command and the environment from the last command that we just ran, and we can do that just by catting them into their equivalent fields for this task. So now we're going to do this unbind command that will remove cap. So by default, namespaces are cloned from their parent. So whatever namespace I have when I run a program, its namespace is going to look like mine unless I modify it like this. So what we're doing is we're removing this process's ability to see the cap directory, which is capabilities. So we're removing its capability to create capabilities, right? We're removing its ability to use picker.fs. And so this becomes a form of security or permissions for processes. So we'll unbind cap, and then I think we just start this task. And because we're creating it by hand, it's sort of run detached, so it actually already ran. We can see its exit code, and we can also see its standard out, which is cached here. But you can see the main thing at the bottom, root only sees task and web. We removed cap from its file system by doing that unbind. So we can dig into that, bind and unbind. So bind is a first-class operation in Plan 9 used to, it kind of works like a symlink, only it also works for directories. So unlike a symlink, it's sort of transparent. It doesn't show like in ls, like it's pointing to this file. It's literally going to look like a different file, but it is just a different name pointing to the same file. So as an example, we could take this worker.js and bind it to also worker.js. And so now there is a also worker.js, and it's always going to be whatever worker.js is. If we modify worker.js, also worker.js changes. But it also works with directories. So there's a directory A that we saw from before. It has an A file in it, which is just has some A's in it. But we can bind A to a new directory C, which gives us a C directory containing a file, right? We kind of created an alias or a link or something, to A, but we called it C. And anything that changes in A will end up changed in C. But the cool thing is bind also lets us bind multiple directories to the same name. So we have this B directory with a B file, and we can bind B to C as well. And so now when you look in C, you've got A file and B file. It's a union of those two directories. So usually this would be kind of a whole ordeal. You have to create a custom file system, whatever, to do this sort of thing in Linux. In Plan 9 and Wanix, it's just kind of a built-in command that the user can use to do all kinds of stuff. And since we're working with and manipulating file systems, right, this becomes a really powerful tool. So we'll use this again in a moment. Let's see. But first, I want to show you VS Code in the browser, because ever since Wanix came out, I wanted to get VS Code running in Wanix. And even though it's not fully working yet, I can show you basically VS Code running in Wanix. So if you have a VS Code for web build, which is just static files, we just need to get those static files into Wanix. So we're going to use that pickRFS capability from before, or even using this capctl command, which also lets us do a command after the new. So this is kind of two commands in one. We're allocating pickRFS, and then we're sending it a mount message, which makes this really convenient. And now cap is an ID that we can use on /cap to get that directory. So those are our VS Code files. So we've got an index.html. So we should be able to point an iframe at it, right? So we could allocate an iframe, append it to the body, and then we'll change its path to this index.html from this pickRFS mount. And look at that. Finally, VS Code in Wanix. You can't actually use it. It's not wired up, but at least that's the UI. So we're almost there. And another weird thing, I don't know if anybody noticed this about our convenience scripts, but this bin directory, we haven't seen a /bin directory, and this is using bin sh in its shebang. So what is that? If we lsla, we can see it's a symlink to BusyBox. And so that kind of explains where all these commands came from. For people that don't know, BusyBox is a single executable that has all of the basic Unix utilities in it. You usually see it a lot in Linux. And I guess what I'm getting at is that this is actually a Linux environment, or rather Wanix is embedding Linux so that we have this compatible shell. It turns out we get a lot of benefits out of this because with previous versions of Wanix, they could only run our custom WASM. And now that it can run WASI, it can run a lot more stuff, but not everything can be compiled to WASM. Like, there's all kinds of stupid technical reasons why you can't do that yet. So for a lot of things, it's nice if you could still run, x86 or something like that. So this idea was in the back of my mind of like, wouldn't it be cool if Wanix had kind of like a Rosetta, Mac OS has Rosetta for running, backwards compatible old architectures and stuff transparently. And I thought that would be cool if Wanix had that. And this led me down a path, as well as VS Code stuff, to play with v86, which is a fast x86 to WASM JIT emulator that runs in WebAssembly. And it's one of the fastest that I'd seen. And so we integrated it into Wanix. And then it turns out you can take the Linux kernel and create a custom build of it and get it down to 1.5 megabytes. So now this emulator that's like 2 megabytes and Linux kernel, you've got like 3 or 4 megabytes, and you have a way to run x86 Linux executables. But the way we did it was, and Joel knows a lot about this because he helped out with this, instead of booting into an initram FS or providing a disk image, we point it, we give the kernel arguments to connect to a 9P service, which is 9P is the Plan 9 protocol. It just happens to be used a lot for emulators and virtualization. But we implement 9P, so basically we could point the kernel of this Linux VM to our Wanix file system or a subset of it. And we could even change it in real time. And so we can use Wanix to create the Linux environment and then use the Linux environment to run x86, but also, we might as well just run the shell in it. You could create a distribution of Wanix that uses a WASM compiled shell and doesn't have any of this stuff, but this unlocks so many things, not just running x86, but because we have an x86 emulator, we can run other operating systems. And so this starts getting into, the Joel vision of running any software from any time in a Wanix virtual environment.
It also enables you to you don't have to use shell scripting for like DOM control. That could be a Node.js program or a Python program, or write it in C. And that's the crazy weird thing about booting Linux inside of Wanix.
Yep. I mean, it's interesting that what I'm showing here almost feels like a little operating system or an abstract operating system. But the point is that you could make your own, like these are primitives to make your own environment that go in some other direction. Maybe it doesn't, you might still have the file system, but you don't have a you have a totally web-based interface to it or something like that. Anyway, so that unlocks quite a bit, and I was trying to be cheeky and keep it a secret that this shell is a Linux VM managed by Wanix or integrated with it. And so to kind of show you how that works, we can now go back to the boot shell helper that we ran a long time ago, and we can kind of see what that's doing as sort of yet another final application of these sort of Wanix primitives, including bind. So we're going to start over and create a Wanix instance with helpers. And so basically what we're going to do here is we're going to create a Linux VM. We're going to create a file system that will be used by that VM. We're going to create a Xterm.js terminal in the browser. And then we're going to wire up that terminal to the VM and then start the VM. And we're going to do all of this through just file system stuff. So first thing is allocate a VM. And there's no options or anything. This is sort of a single purpose VM at this moment that's made for running a Linux VM, but you can imagine this more general being able to actually run different kinds of virtual machines in here, which on its own just is pretty cool. So anyway, once allocated, a virtual machine, again, super specialized, it doesn't have a lot. It has a control file that we can send commands to start and whatever. But unlike a lot of other systems, you can actually also create files in here, or at least create bindings that will have meaning to the VM. So for example, we need to make a file system for this VM. And again, this file system for the shell that we were just using is basically a BusyBox environment. So that's, it has a bin with that we can also put our shell scripts that we've been using in there. And, just a couple of other Linux specific directories. These were all kind of packaged up and then embedded in Wanix, and they're available in this, I guess you could call it a hidden directory, but this is something that Plan 9 did. All their kernel file services have names. They all start with pound. So it'd be like something like pound C for console. But anyway, you don't see these in the file system normally, and they're only available in the root namespace. But it's a way for Wanix to expose things to, the system administrator or the system builder that aren't necessarily going to be in the environment that the author is creating. But this shell is pretty much just a full Linux environment, so we can use that as the basis for our file system. So we can just bind that shell directory to an fsys directory that it's going to make under VM1. And then we can also, because we want to use Wanix from this environment, we can take our Wanix root, which is, cap, task, and web, and also bind that to fsys. So the end result is a union of the Linux file system and our Wanix root file system. And so this is what this system is going to boot with, kind of just by convention of being at fsys. So now we're going to create a Xterm.js terminal, which we've sort of pretended is like a built-in element on the DOM. You can create divs, iframes, scripts. Obviously, in theory, you could create any kind of element. These are the ones that are useful in this context, but we also threw in Xterm. So we could allocate xterm and then append it to the body. And this element has adders we could inspect, a control node. We can look at its inner HTML and its type. But we also have this data file, which is unique to xterm. And this is wired up to the API for xterm's reading and writing data. So basically, this is our API to xterm. We don't have to use the xterm JavaScript API. We can just use this. We could write to data, and it writes to the terminal. So, right, this is what a terminal or TTY interface would need as well. If we were to type in this terminal, we could then read from data and get that data. So here I'm just doing a reset to clear it. So now we need to wire it up to the VM. And so because it's just kind of a plain text file interface, we can just bind it to TTYS0, which in Linux, that's the name of a console over serial port. So serial port 0. And then using that to have a TTY session. So basically the VM is going to open up TTY S0 to read and write its console shell stuff, which will ultimately be reading and writing to data, which you can see here. If we write to TTY S0 now, it again writes to the terminal. So now we just have to start the VM now that has a file system and a terminal. So we can write to its control file and ignore this error. But over here, there we have our shell that we're using from before. That's, I think, everything that we have for this demo, this preview release. So Wanix is already a primitive. It's not for everybody. It's for, Unix hackers and system builders and people that are interested in building this kind of plumbing might find some interesting uses for this, especially with the fact that it can run all of this stuff in the browser, which is why I think local first people might be interested in this. And of course, my intentions with this are for virtualizing development tools so that you can build self-hosted applications, self-hosted malleable applications. So that should give you an idea of what Wanix is capable of. Now, in a way, it's not. So this is a preview release because it doesn't have everything from before. And, now that it's this virtual environment toolchain, I'm not sure that it needs to be a usable operating system or environment. And so, really it's kind of a little toolbox. And what we just went over was, some of the tools that it has in that toolbox for building. In a way, the shell that we created for Wanix is an example of an environment that Wanix can put together. And so in that way, it's sort of dogfooding itself. Anyway, you can go to wanix.run to play around with it. You can check out the main branch on GitHub. And in the next day or so, there will be a actual release cut and a little bit more concise version of this demo video. What do you guys think? Actually, Tara and Joelle, what do you have any feedback on this demo? Because this is actually, I think, the first time either of you have seen this, right? Sort of all put together.
Mm-hmm. I have to say, I appreciate Joelle giving like examples that made some of it make it a little more concrete sense to me. I mean, I know you give examples too, but just like a different sort of perspective.
Yeah, my examples are all vague and abstract. Joelle, yeah, I guess maybe I showed you, or maybe I went over this with you.
I saw a really early version of this. I was surprised and delighted by the binding of that data file from the xterm into TTY_S0. I noted it wasn't /dev, or it wasn't dev TTY_S0. So was it just in root?
No, it's just a special, it's not, I called it TTY_S0 because that's the closest appropriate name that it would be in Linux.
Mm-hmm.
But it's not actually the dev TTY_S0 file that would be in the Linux environment. I'm really just using it as a way to say, I'm going to open this and I've wired up the serial port on the VM. So it has the same name, but is not the exact file that would be used in there. If that makes sense.
In the Linux VM, what does it think it's talking to?
Well, in the Linux VM, it thinks it's talking to the serial port.
Oh, got it. Okay, so it's bound into the serial port. It would be really cheeky if it was binding to dev TTY_S0.
Yeah, I know. Yeah, I mean, you keep saying stuff like that, and I'm like, would that work?
I mean, probably.
Yeah.
I mean, we'll see. I was originally going to say, like, oh, that arrow as the shell prompt doesn't show that it's a bash shell, but then the reveal came later. So that actually might be a fun trick you could do, where you could be like export PS1 equals $, and you're like, it was bash the whole time.
Yeah, I mean, that was kind of the idea. Is like, oh, we're in Linux the whole time. But it doesn't have to be that intense of a reveal. But I think it helps not to confuse things by trying to explain it up front. So I think it actually helps to explain it at the end.
What about people in the chat? Any questions or thoughts from any of y'all?
They're all lurkers. They don't speak.
They don't speak, like the No Doubt song. Well, that you should all chime in. I would like to know if anyone's given it a try. I should give it a try. But yeah, so you're going to be making a video, putting this up, and then what? Is that gonna what's next in the world of Wanix?
Well, I can think of a lot of things. I'm going to try and put most of those ideas into issues or discussions so that there's some kind of roadmap and people can contribute. And ideally, if not at this preview release, at the final release, Wanix is useful enough for people to actually use and play around with. It's weird because it's not purely about usefulness. It's sort of exploration, It's like, oh, I'm interested in Plan 9 and what Plan 9 had to offer. Here's another way I can play around with those ideas.
Yeah. You got a question. This is a good one.
Oh, it looks like it was. Oh, there's a lot. Sorry, my chat was not up to date. Do you get the memory footprint as the file in the same directory for long-lived tasks? Memory footprint as a file.
That's when you were showing, doing like the mounting of, I believe that's when you were like showing off mounting in the WASI stuff. I also think it's sort of already there because it's Linux. Don't you get that in proc? Like, can't you go into proc and then the PID and then get that information?
Okay. Yes. And you could here too, because you have, I think you have /proc, but the task is sort of a separate abstraction managed by Wanix. So you might not have a Linux shell that you could use an actual /proc, but also you might be running processes in separate VMs. So no one VM is going to have, all of the tasks that you're running. Wanix will be the thing that has all the tasks. And the other thing is that a task is general. There's different types of tasks. There's a WASI task, which is specifically set up for the browser environment where it'll run it in the virtual machine in a web worker. We could create another task type for running the old Wanix executables. Not that we need to, but that is a way to do backwards compatibility. But really the point was you could also create a task that is just a wrapper around a native process. So in the cases where you might use Wanix outside of the browser, which I didn't really get into, but if you remove all the web stuff, the core virtual file system and task stuff is still there and will work. And so there's actually sort of an in progress, in development subcommand of the Wanix CLI tool called mount that will let you, if you have Fuse installed, it'll let you mount the Wanix file system, the root file system without the web stuff, to your host system's file system. And the idea there was to, make it easy to explore some of the Plan 9 ideas at the actual host level. But in those cases, you might, running a task in that instance or that build of Wanix doesn't mean it's going to be WASI and run on a web worker. It might be that it's just a native process that it's managing. So task is sort of like a meta managed resource. Whereas /proc will always be just the processes that particular VM is managing. Or you could think of a network scenario where maybe you're remotely running, right? Using the task abstraction to run remote processes that you want to manage through the task interface or in fact, there's all kinds of interesting experiments in terms of like, how would you model a network cluster manager? What is the simplest form of Kubernetes here? These are all interesting ideas that I'd like to explore. At some point, they're not on the critical path right now, but it's just one of those things where making this primitive is making me think about these things and hoping people are interested in exploring those areas. But let's see, what other questions? Sounds really odd, but I may want to integrate my game making tool in Wanix. Gold Buick, yeah, actually, I mean, in the same way I'm interested in building a game making environment. Really, you can make any kind of environment. We have an editor in there, so you can make, so once VS Code is integrated, it's integrated in a way that lets you also create new VS Code extensions so you can kind of use the environment to extend the editor, and so you could build a sort of specialized game IDE with it. And I probably will at some point as well. Anyway. Wanix equals experiential philosophy. Could be fun to reuse some of A-frame in there. Oh yeah, A-frame.
What is A-frame? What?
It's like they wrapped 3JS with React style composition. So you can make 3D scenes out of what looks like React.
So you could make a viewer for the images on your file system and then render them in 3D.
Yeah. I think a big theme in not just Wanix, but in my work is like playing with the idea of the representation as most people don't think about the represent, like the file system. Most people think, oh, when you say the file system, you're talking about the file set, the concrete file system. Yeah. The file system as an abstraction is the API for the file system. And a lot of Wanix just falls out of the idea of what if you just have that API? What if the file system was a pure abstraction? And so that's, I guess that's leaning into its representation. But also, I was at a conference, I think it was a local first thing, and there was some it's unconference style, so someone set up a talk or a discussion on like the future of file systems or the future of files or whatever, and they fell into this trap that I see people do a lot, where they're confusing the UX of, their operating system's Finder or Explorer or whatever, and thinking that's the file system, when that's a UI to the file system. And yeah, you could create, some people now are arguing like how the file system is terrible because, you only have, that's not how we want to organize information. We want to organize information with like tags and blah, 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 blah. Search for everything, blah, blah. People have all these ideas of like how you can do it better. But those are just different views of the same thing. It's like,
yeah. Well, and that's actually reminds me of feedback on your slide. I really liked the slide you had initially showing how file systems, traditionally people thinking of them as mapping to physical devices. And I was going to say, I think you should have it show, mapping to a hard drive or RAM or, a USB drive or to a program, right? It could be linked to code. And I mean, in the chat, they're talking about recreating the one scene from Jurassic Park, which was, I remember when I first saw that, I was like, that's not Unix. And then I get older and I'm like, no, it actually was Unix. It was SGI, and that was a real file system browser. Yeah. But that goes to what you were saying about confusing the medium with the message, as it were. And so I think the people in the chat, Gold Buick and Nevizona, are kind of getting it, that like, yes, integrate your game making engine. Yes, integrate A-frame.
They're also talking about
And-
how what if computing was just a CLI and XR. That's kind of funny.
Yeah.
Like, don't even bother
Well-
with this 2D bitmap graphics UI stuff. Just have a CLI and then some kind of XR.
And that's the thing, right? That teletype. I mean, that's why we have terminals, because there was paper way back in the day. And Navizone, if you haven't checked out Folk Computer or Dynamic Land, that's another cool way of interfacing with computers that is not just
kind of a
weird.
I wonder if technically it falls under XR. Oh yeah. Okay.
Good. Very familiar with Dynamic Land. Excellent. Hopefully Folk Computer as well.
The
One
fork.
of the offshoots. The fork. Oh, good. Projection mapping is XR. Yeah, I don't like. I mean, I spend a lot of time. Just search for folk.computer. FOLK. I can type. FOLK. Yeah. When people say XR, I usually think they mean like glasses that overlay stuff in the real world. But for those who don't know about Dynamic Land, those were projectors and cameras in the real environment. And so you didn't need any special gear to deal with this mixed reality computing. You just need to be able to use your eyes. And that's a whole other topic, but it fits tangentially into the Wanix vision, which is like simple interfaces that allow for a lot of generativity.
Yeah, it's
but,
funny because it gets at kind of the difficult way of communicating what Wanix is for or could be for. But, there's nothing in this presentation that really gets at XR or anything like that. But, there are people that definitely, I mean, we're talking to them, that kind of are imagining a world of, a paradigm of computing that is, XR oriented or something like that. And I love that stuff. It doesn't have to be XR, but like, future of coding, I think was, there's a bunch of the all ink and switch stuff, just a lot of these kind of like progressive, thinking about the future of computing. Yeah, is there a future of computing? I know future of coding maybe, but is there a future of computing? But anyway, okay,
yeah.
Future of coding.
That's...
This, I mean, in a way, I'm trying to make tools that would be helpful for people that are interested in that space and building stuff in that space. Because, one, virtualizing dev tools lets you integrate existing development tools into whatever this can be. When a lot of people want to reinvent the universe, reinvent computing, they end up making a walled garden because, like Smalltalk or whatever, it's like they're only looking inward because they're creating the future or whatever. And then it ends up being kind of a opaque, all or nothing kind of thing. Either you do everything in Smalltalk or you just don't use Smalltalk. Because the Smalltalk VM is sort of really designed to be its own whole world. It's not really designed to integrate as well with its host environment or whatever. And so that's another reason why I think of this as like this virtual environment abstraction. The fact that it's virtual means that it is what is the metaphor? Like you can control it via software.
Well, and that's been the real rewarding part of all this, is like being able to boot the VM basically instantly is surprising and powerful. Like I knew in theory, you could boot VMs, but for me, VMs were always like a separate software like QEMU with 1 million command line flags. With v86, which is the WebAssembly based x86 emulator that's inside of Wanix, it's basically instant, and it's surprising.
Well,
And it's been
some people, cloud people, are like all about that, like, I don't know, microsecond,
sure.
cold boot time, whatever. It's not anywhere near that, but it is surprising just how, like, I'm used to when I start a VM that it's got to go through that, the kernel, the BIOS, the kernel, and it like takes a moment before it gets into the actual thing. So
Yeah.
making systems around VMs has always been obnoxious because you always have to deal with that. So you end up having to like boot it, take a snapshot, and then from there just boot from the snapshot, which has all this extra complication. And yeah, I was surprised that if you just cut a bunch of stuff out of the kernel, the Linux kernel, it boots pretty fast. So yeah, every time, like if you go to wanix.run, like the time from the gray to the prompt is basically the VM booting. And it's not like sub-second yet, but I mean, the bang for buck, like it's fast enough that we don't have to do snapshots. Yeah. It's also crazy to have a Linux virtual machine primitive that you just point it to a file system as opposed to creating an image for the VM or whatever. Like I've always hated the hassle of. That's kind of why containers and Docker is cool, because one, Docker is its own tool chain for creating those environments, which is pretty significant. And yeah, it feels like you're just defining what goes in them as opposed to, I don't know, dealing with CPIO or figuring out how to get Linux to boot properly with an init FS, or is it going to use, I don't know. It's just figuring out how all that stuff worked, but surprising how simple you can get it.
Oh yeah. And even that is not simple enough. It can be simpler.
WebVM, yeah, what about them?
I think it was just brought up. I remember, I forget what it was. There was a project.
WebVM is the one that connected to
it's that
Tailscale.
Chirp X. Oh yes, yeah. Why were we looking at a bunch of stuff? It wasn't just v86. We were because v86 has a 32-bit limitation. It can only run 32-bit executables. So think about it as it's essentially a computer from the early 2000s. And so I remember looking into other things. At this moment in time, it's probably, if anything's going to replace v86, which is a great project, by the way, like the code, I'm always impressed with the internals of it. But if anything's going to replace it, it'll probably be a WASM compiled QEMU, which looks like it has 64-bit support and it works, but it's slow. But
yeah, it seems like I think because WASM is 32-bit, or there's some constraint in WASM so far. So anything 64-bit is sort of like emulating it and is slow. So it's in this weird place where if you actually want to get 64-bit, you can get it to work, but it's probably going to be slower. Or, WebVM and maybe even web containers. The problem with those, to me, is that they're not open source. They say they are, but
they're not.
Some core technology that's used in it is then at least semi-proprietary.
And this also isn't like a ideological thing for us. I would say, at least for my part, having the source of v86 was useful because I've had to dive into it. Like the 9p stuff was extremely useful to have. And yeah, I would be very frustrated. I mean, every part of v86 that I've had questions about, you dive in, you find the code. It's great.
Yeah, it's a very hacker project. Like just everything in terms of the licensing and how it's put together, and it's a little messy here and there, but it's not super, it's getting better. It's not super well documented, but if you do read the source code, it is pretty good. We're gonna probably wrap things up soon, but Gold Buick, what's the question?
Good question.
Well, at this point, all the cool stuff that you can do with Wanix somewhat depends on using v86 to give you a Linux shell. I mean, you could create a pure WASM shell and whatever, but and v86, even though it's WebAssembly, it still makes a lot of assumptions about where it's run. It's not WebAssembly that's made to run anywhere. It's WebAssembly that runs in the browser. So, so even though a version of Wanix could be embedded in, you know, a non-web thing, you could, like, one way to integrate it is where it actually runs a headless browser environment. There's a Wanix console subcommand that kind of gives you an idea of what that looks like. It's literally running Wanix, but in a hidden browser window, and then letting you interface with it there. That's nice because now you have the whole Wanix stack. And, you know, maybe it's not so bad that it's not Chromium. It's whatever the default browser for the operating system. So you could embed it in any I mean, if you're writing Go, it's really easy. If you're writing something else, we'd have to talk about that, and I'd have to make like a bridge library or C API or something. But I mean, the general idea is that it was designed to be embedded or mostly embedded, like the file size and everything, even though, you know, the core VFS module is 2 megabytes, which is pretty small. That still sounds big for the web, but in terms of what it gets you as a system, like maybe it's worth it. But the idea is to try and make it as small as possible, so that you could reasonably embed it in something else. And then the technical details of how you would integrate with it are kind of running Wanix in another web app. That's the easy part. Like I showed Wanix being added to a blank page on purpose because it is a library. You can just put it in another web app, and then use it like a library. But you could also build a web app in it. So you know, there's a lot of ways it could be used, but it can definitely be embedded in another web app. Like that's basically what it is when you go to Wanix.run. Cool. All right. Well, thank you, Gold Buick, for the questions, for hanging out. Thanks, everybody else. Tara, do you have anything to add?
I don't.
it's the end of a Wanix from scratch stream series. I have an idea for a new stream series, but we'll talk about that later. No, we'll talk about it later.
Not even a teaser? Come on.
Well, you know, maybe it would be fun to do, you know, we did all this low-level plumbing stuff. Maybe it'd be fun to do more design stuff in Figma.
Ooh.
Which also, because now there's enough building blocks with like visual representations that I can kind of think about them visually, and then we can make kind of a design language, you know, just build out, basically just sketch out, you know, the rest of Tractor stuff. Which is all high level conceptual stuff, and so that could be a little bit more accessible to people, while also giving an idea of what's I'm actually thinking in my head, and making it more tangible, like if it's represented in Figma somehow.
Yeah.
So that's an idea. It would kind of put a lot of, I would imagine you would be driving Figma, so it's kind of up to you.
Yeah, well, I'm sure we can come up with some sort of components.
Yeah.
I also like the iPad for just like sketching stuff. At least just maybe starting there.
Yeah. I used to have a setup where my iPad would let me draw on the screen for the stream, but
yeah, we can do that. You can do it with QuickTime actually.
Yeah, there's all kinds of. We'll probably just share your screen doing Figma, but anyway, that is just an idea. But I think the other big thing, I think what's next is not necessarily Wanix, but Aptron. So revisiting, going back to the Aptron plan and pushing that forward, and really getting Wanix to this point was also like getting Wanix to the point where it can solve problems for Aptron. So yeah, I'm excited to see what happens with Wanix, but I'm mostly interested in using it for other stuff now, and it will probably be Aptron.
Yeah, it'll be cool to see all this stuff coming together.
Yes, finally. I guess we'll wrap up. It was definitely longer than 30 minutes, but I think it went pretty well, especially for me not having finished it. But yeah, thanks everybody. Thank you, Joelle and Tara, for joining for this.
Yeah, happy to.
Yeah, it's cool to see.
All right, time to say bye to everybody.
All right. Bye-bye.
Bye, everybody.
Bye.